All right, in this example, we want to graph this function and label the asymptotes and intercepts and state the domain and range of this function. So we have y equals 5 log of x plus 1. All right, now you might recognize this as a transformation of the basic log function, right? We've changed the input to x plus 1, so we have an inside change here, which shifts the function to the left by 1, and then we have a factor of 5 applied to it, an outside factor of 5, and so that's a vertical stretch of by 5. So I tend not to like to do it that way, just because I feel like I have to rely on my memory, and I don't always trust my memory. So I like to verify that, those transformations. Now, I've done it enough times. I know that this is a shift to the left by 1 and a vertical stretch by 5. But we can always make a table of values and plot points. So I can always make a table of x and y values for this function. I put in values for x and calculate what y is. Now with a logarithm, I want the input to be a nice value, especially if I don't have a calculator, which oftentimes you may not have a calculator. On a test or a quiz, you may not be able to use a calculator. So I want to choose convenient values of x so that the input is easy to evaluate. And the input to the logarithm is x plus 1, right, in this particular function. So I know that it's easy to evaluate powers of 10. And I know that the asymptote occurs when the input is 0, right? So I'm going to choose values of x plus 1 to be 0 and 1 and 10, or I could choose 100 too, but I can see that from the scale on the graph I'm given that would give me values that are off the graph. So let's just start with these values. So these are the inputs to the logarithm. The x plus 1 value is input to the logarithm. So what value of x would give you 0? Well, so if I have an x of a -1, right, then -1 plus 1 is 0. And I can't actually evaluate the log of 0, right? The log of 0 is undefined, right? So this is undefined, but that's where the asymptote occurs, all right? So now I know that the asymptote is at x equals -1, all right? So now if the input to the logarithm is 1, right, x plus 1 is 1, then x would have to be 0. And I know that the log of 1 is 0, right? So this is going to give me a 0. If the input to the logarithm is 10, right, then x would have to be a 9, right? 9 plus 1 is 10. I know the log of 10 is 1, so this would give me 5. So now I have some points that I can plot. And so I'm going to have an asymptote at x equals -1. So right along through here, let's see if I can draw that in as a dashed line. All right, it's kind of, those numbers are kind of in the way, but you can kind of see that this is going to be the asymptote x equals -1. Okay, so it's undefined at that point, and I can't take a log of a negative number, so I know now that the domain has to be, I can actually write that x is greater than -1, or x, if I want to write it in interval notation, I can say x is an element of -1 to infinity. All right. All right, so then I have these points. I have the point 0, 0, so my graph goes to the point 0, 0, also goes to the point 9, 5. Okay, and so now I can just sort of sketch this in. There's no reflections or anything, so I can just kind of draw this, right? And then I've got to draw it so there's an asymptote. Okay, so you get the idea. My line's a little wiggly, but you get the idea that that's what the graph of that function is going to look like. All right, so we have the domain. We found that the domain is -1 to infinity, and so what's the range? The range is the set of all possible y values. So, and really, y can be any value. So we can say all real numbers. Or if we want to write it in interval notation, we could say y is an element of negative infinity to infinity. Okay, so we know that the range of the regular log, the common logarithm, is all real numbers, and if we multiply all real numbers by 5, we still get all real numbers. So you could think of it that way as well. All right. I will see you in the next video.